Alright, so it's a crash course in quadratic equations. Everything that we all know about quadratics. So, first off, what makes a quadratic equation a quadratic?
A squared and a not squared and a not even with a variable.
Okay, do you need all three of those?
No.
No, as long as it has a squared term, okay? So quadratics must have a squared term. So what we're going to do is we're going to do this by taking an example of a quadratic and then just playing about with it and seeing what we can discover from it. So for example, let's say we've got a quadratic which is y equals 2x squared minus 6x. Okay, so this is definitely a quadratic because it's got an x squared term. Yes? Now, what does the shape of this look like? If I was to draw it, what is it going to look like? Okay, parabola, okay? Quadratics always take the shape of a parabola. You find it good. They always take the shape of a parabola. Okay, that's all very well, but what does a parabola look like?
It's a U, pretty much.
Okay, yes, either a
U or
a happy face
or a sad
or a
Oh wait, that's not
sad face, okay?
Yay.
Parabolas, quadratics will always take one of these two shapes, okay? Now, how can we determine whether it's going to be a happy face or sad face by looking at this?
If it's positive or negative.
If what is positive or negative?
In front of the Hey,
Right,
I was
okay.
answering questions. Oh, sorry. It's a happy face.
Okay, so this is
So 2 being positive.
positive. What's the number in front of the x squared called? Or coefficient, alright. Positive coefficient in front of x squared. So that means we have a happy face.
Yay.
So it is going to be a definite U shape. All good? Right, if I was going to actually draw this, what would I do? Okay, now substitute what? Okay, values into the x. Now, I know it's definitely going to be a happy face. Do I need to substitute in like lots of different values? What are the most important values to sub in? 4. No, sorry, like 0 for which x or y? Okay, right, so what we're going to do is, if we let x equal 0, then this tells us then y is equal to, well, it's going to be 2 times 0 squared minus 6 times 0. So when x is 0, then y is equal to 0. So this is telling us, when we're looking at x is equal to 0, this is producing our y intercept. Okay. So this is one point that we have already, x0, y0. What else could we do? So that's our y-intercepts. What other intercepts should we work out? The x-intercepts. Okay, so how do we work out the x-intercepts? Right, okay, so if y is equal to 0, then I end up with 0 is equal to 2x squared minus 6x. Now, how do I go about solving this for x. Right, you factorize. Okay, now are you always able to factorize? No. So if you can't factorize, you use the quadratic formula. Okay, now we're going to look at all this different type of stuff. Okay, so if I'm going to factorize this, what way am I going to factorize this specific equation?
Two outside.
Yep, the 2 outside.
And then a bracket with x inside.
Can I take anything else out apart from the 2? Apart from the 2?
Oh, 2x.
Right, okay, 2x outside.
And then an x inside.
Yep, minus
3. Yeah.
3. Okay, good. So once you factorize, if you can factorize, we can see that either, because these two things, 2x is multiplying the x minus 3 and it equals 0, will either 2x is equal to 0 or x minus 3 is equal to 0. Okay? If the product of these two things equals 0, then either one of them can equal 0. In that case, it tells us, well, x is either equal to 0, or in this case, x is equal to 3. Right, and these are our x-intercepts. Is that okay? So I've got, let me just write up here. Now this makes sense because I've got my y-intercept, which is 0, 0. I've got my x-intercepts, which is actually, well, 0, 0 again. But also, what's the other one? Well, not 0, 3, 3, 0, okay? Remember the x-coordinate comes first. Yep. So if I was to draw this, and I'm going to do it on Desmos. So the equation is y equals 2x squared, and what was the next part, sorry? Minus 6x. Okay, we can see from this. Okay, here is 0, 0, okay, that's my y-intercept and x-intercept. Here is the other point, which is 3, 0, okay? What are these values, what are these two values called, okay, apart from x-intercept? There's another word for them, beginning with R.
What is the next
You not heard of this word?
No.
These are roots, okay?
No.
Okay, so roots are where it goes through the x-axis, okay?
Is the same thing to x-intercept?
Yes, basically your x-intercepts. Okay, so we've got 3, 0 and 0, 0, okay? It's where your graph goes through the x-intercept, x-axis, sorry. Now, what else? So we've got our happy face. We know where our x-intercepts and our y-intercepts. What else do we know about this graph? Okay, the vertex. Now, the vertex is the... Yep, or the highest point, okay, depending on whether it's a happy face or a sad face. So this point is our vertex. Now, looking at this, okay, I know that this is 3, 0, and we're going to do this a different way as well. And this point here is 0, 0. How can I work out the vertex from the information I've got?
Find the middle point.
Yeah, find the middle point, okay, because I know that my parabolas are always symmetrical. Good, okay, so if my vertex is, if my parabola is symmetrical, my vertex is going to be smack bang in the middle of these 2 points. So what is the x-coordinate of my vertex? If it's
1.5.
1.5. Good. So it's between 0 and 3. So it must be 1.5. Okay. Now, how can I work out my y-coordinate then? Right, okay, we could sub it back into the equation. So remember, this is my equation. Okay, 2x squared minus 6x. If I put 1.5 into my equation, it is going to give me out my y-coordinate. Does that make sense? Yes or no? Okay, so I'll put that back up in a second. I just want to put this into my calculator. So I've got 2 multiplied by calculator, 1.5 squared minus, the equation was 6 times 1.5. So I can say my y-coordinate is going to be negative 4.5. The previous one. Okay. So negative 4.5. Okay? So I just get my y-coordinate by plugging in the x value into my equation. Okay, so that's one way that we can work out the vertex. That's one way that we can work out the roots. Remember, roots are just the x-intercepts. Okay, so far? Say again? Okay, can I get rid of this screen? So this is the original equation that we started with. Okay, so this is the very first equation. Okay, so let's go back to here. So we've worked out our vertex. Just write it in as well. As being one and a half.
Yeah.
And negative 4.5. All right, so that is factorizing. Okay, now this form is called the factorized form. Now, if I couldn't factorize, what could I do? Okay, I could use the quadratic formula. Okay, so we're going to actually just do that quickly as well. And then we're going to do it another way. Now, do you need to remember the quadratic formula? Nope, you're given to it in your formula booklet. So the quadratic formula is, write it over here, x is equal to minus b plus or minus square root b squared minus 4c divided by 2a. And I'm going to write my formula, my equation down again. So, Marco, what is the value of a for my equation? 2. 2. Lely, what is the value of b? Negative 6, okay, so b is the value in front of the x. What is the value of c? 0, because there is no constant term, okay? So if I put everything into my formula, I've got negative b, okay? So, oh, sorry, negative b, so which is negative negative 6. What's negative negative 6? Right. Plus or minus square root of b squared, write it all out, minus 4 times 2 times 0, all divided by 2 times 2.
Wait, is it 0 or is it 1?
It's 0, because if it was 1, there would be a plus 1 there. Okay? Alright, so this part goes completely to 0. When I square a negative number, it gives me a positive number out. You okay, Samara?
Yeah.
So I've got 6 plus 6 over 4. I've also got x is equal to 6 minus 6 over 4. So this gives me 12 over 4, which is 3. Let me write that a bit neater. And x is equal to 0. Okay, which is what I would expect. Okay, I've got x is 0, x is 3. Okay, so this enables me to find the x-intercepts. Yep, the roots. If I wanted to find the y values, what would I have to do with these? Sub them back into the original equation, okay, to get the y values. Does anybody know what this thing underneath the square root sign is called? B squared minus 4ac. Should.
No, what is?
B squared minus 4ac.
No.
Okay, so our b squared minus 4ac is very important. It has a special name.
What is the first letter?
Its first letter is a D.
Discriminant.
The discriminant, okay.
No idea.
So in your quadratic formula, you've got this part called b squared minus 4ac, which is called the discriminant. Now, does anybody know what the discriminant tells us?
Yes.
Okay.
We did that.
Well, okay, I'm not going to tell you, but I'm just going to point out that in this example, what can you tell me about the value of the discriminant? What is it equal to? No, that's equal to... This, yep, in this example, the discriminant is equal to 36. Is that okay with everyone?
It shows us the x-intercepts.
It doesn't show us the x-intercepts.
It tells us.
Okay, we'll not guess. We'll come back to it in a second. Okay, we'll do another couple of examples and hopefully you'll see. But I want to point out that this value of 36 is a positive number. Okay. All right. We'll come back to the discriminant shortly.
Okay, it shows us that it is a happy face. Well, why did you point out that it's positive? Also, x is 3 and 0.
The next form that we can put our quadratic into is called the vertex form. This is everybody's favorite. That's sarcasm, by the way.
Oh, wonderful.
My vertex form.
Can you give another way of finding the vertex?
This is another way of finding the vertex. This also enables us to find the x-intercepts as well. And it is something that you will probably definitely be asked to do in diploma level, okay? But you have to know it for MIT as well. And vertex form looks like this.
Is this just pretty standard?
No, this is for extended as well. Standard and extended, sorry. So this is our vertex form. You will have done this, hopefully, last year. And now to get it into this form, right, so put a quadratic in this form, you have to. Can anybody remember the name of the method? Anybody?
Complete the square.
Right, complete the square. So we'll go back to our original equation. Okay, so if I want to put my quadratic into this form, okay, can anybody remember the first step that we need to do?
Figure out what.
We need to
Factorize.
factorize, okay? Regardless, whether it factorizes evenly or not, you have to factorize, okay? Because we do not want any number in front of the x squared, okay? So we factorize is our first step.
Oh, why is it? Why square? Yeah.
Oh, there we go. We just factorize out the 2.
Is there a reason why we're using square?
No.
So it's like,
No reason. It's just, I guess because I'm going to ignore this 2, okay? I'm going to keep writing it down, but I'm going to ignore it for the rest of the procedure, okay? Can I scroll this down to here? Is that okay?
yeah.
Right, our next step. I'm going to write the 2 down again, but I'm going to ignore it and not do anything with it. We write down what we've got, okay? And I'm going to, just do it in a different color, add half of the middle term. So what's the middle term? The coefficient of the middle term. Okay, and I'm going to write it as a fraction though, because it's going to make it slightly easier. And we square it, okay? So half the middle term squared.
Wait, it's what middle term? What?
This is our
No, this
essentially. Okay, no, okay, I see. Hang on, I see what you mean. Why is this the middle term, okay? Because there's no last term, okay?
Right.
And so this is what we call the middle term, okay?
Right.
Because there would normally be a constant after it,
When
okay?
you said middle term, I thought the same thing you just said, but with the 6, because,
Yeah.
yeah.
All right, so we add on half of the middle term squared. Now, in order to make this line the same as this one, what do I have to do?
Subtract.
Yeah, I have to subtract it off again. Now, this will become clear in a second, hopefully. So can we agree that this line and this line are the same things? Is everybody okay with that? These 2 lines are exactly the same? Okay, I've just added something on and I've subtracted something off. Now when we get it like that, the nice thing is we can just go straight to our answer. Because these 3 terms I can combine into our squared part. Oops. So it's going to be x, because we've got x squared here, and we're going to have 3 over 2. So these 3 terms combine into the first part. If I was to expand this, I will get these 3 terms. And then I've got this part, which is, if I multiply it out, 9 over 4. So that's that part. Okay? So far? squaring this whole thing? Because if I was to multiply this out, I'm going to get back to these three terms. Okay, now the whole point of this, remember, is I want it to look like this, okay? I want some number multiplied by this squared term, so I've got some number which is going to be multiplied by this squared term. Okay? I've got my 2 outside these big brackets. Now what I'm going to do is I'm just going to multiply it out, okay? So if I do 2 multiplied by this bracket, I'll go on to another page in a second.
Why do we have to flip the 3 over 2 there in the first place? Why do we put it? Oh, never mind. Wait. What's your question? Why do we have to put the 3 over 2 there if it's just going to subtract 99?
Because in order to be able to write it out like this. Okay? Remember, my whole idea, my whole goal behind this is to take this equation and write it in this form.
Then how do we get the 3 over 2?
Squared?
No, in the third line.
Here?
Yeah.
Okay, because we know that if I was to multiply out this x minus 3 over 2 squared, it's going to give me these 3 terms. Okay? And that's always going to be the case. Okay? I'm going to now do the 2 multiplied by this part. Let's do a different color. So 2 multiplied by 9. Yep, and it's all over 4. And I've done it like that because that 2 is going to cancel with 2 here. Nice. Oh, hang on. Mistake there. Yeah, it should be 2 times 9. So whenever I write it out, I'm just going to write it up here so we have enough room. And that is now in our vector form, okay? So remember, you always add on half the middle term squared, subtract it off, okay? First 3 terms collapse into this first part, and then you work out the remaining part. Now, looking at our vector form, why is this important?
Wait, is it vector form or vertex?
Sorry, vertex form. What does this tell us?
Oh, it gives us the vertex.
It gives us the vertex, okay? How does it give us the vertex?
Because negative 9 over 2
Mm-hmm.
is equal to negative 4.5, which is what we got when we graphed it earlier. So that's the y-intercept. And then 3 over 2 is equal to 1.5, which is what we got as the x.
Right, okay, so this point gives us, okay, now the way that we do this gives us the x-coordinate of the vertex, except you always change the sign, do it, okay? So this is minus 3 over 2, so we make it positive. This one, we just leave as it is. Whereabouts here? I could, it's 18 over 4, and then that's just going to simplify to 9 over 2. Here, okay, because 3 squared is 9, 2 squared gives us the 4. No, because remember, multiplying fractions, you multiply the top only. So it's like, so we've got 2 times 9 over 4, so it's 2 over 1. 2 times 9 is 18, 4 times 1 is 4. And then that simplifies to your 9 over 2. Yep. Alright, so this also provides us what with our vertex, okay? So that's another method for getting it. Now you have to be able to put quadratics into vertex form, okay? okay, what I want you to have a go at is the following. Okay, I want you to for the quadratic, y equals 2x squared minus 5x minus 3. Actually, I'm going to give you 2. You know what? I'm going to give you 3.
What? No.
Yeah. I will tell you in a second. I want you to find x and y intercepts. Okay. And part of this will involve, so that means you have to factorize if possible. Okay? No. I want you to use the quadratic formula. Check your x-intercepts. Or maybe it may be the case that you can't factorize it, so you have to use a quadratic formula anyway. I want you to put each equation in vertex form. And hence find the vertex. Nope. And the last part is to do me a sketch.
This is going to take a lot more than 15
Each
minutes.
graph. It really won't, okay? It really shouldn't, okay? Because finding the intercepts, finding your y-intercept should be easy. You're just putting x equal to 0. Factorizing it if possible. Actually, you know what? Before we even get to there, before we get to the sketch, sorry, there's going to be another part. I want you to find the discriminant of each. Yeah, because if you're working out the discriminant, if you're working out using the quadratic formula, you're pretty much doing this anyway. And then your last part is the sketch.